All right, good morning, sugars. Here we go. All right, section 1.2, we are describing distributions with numbers. We've already done a little bit of it, so here we go. We are going to be looking at center spread, variability, like how does it vary? Where do the numbers fall? Quartiles, 5-number summary, box plots, variance, standard deviation, and what is resistant to outliers. So some of it you might already know, some of it will be new to you, okay? Like I said, I'm going to go easy on this first chapter, and I'm spreading it out just a little bit for you guys, okay? Let's see if I can get this to work. And there we go. All right, so again, to describe a distribution, shape, center, spread, you can add to the bottom of this outliers, okay? Add to the bottom of this outlier. So they want to see, is there something that deviates from the mean and it's unusual, okay? Is it unusual? Why is it there? Is it naturally occurring, or did we just mess up, okay? So to look at the shape, y'all, you are going to use a histogram or a stem plot. Or, check this out, what if they give you no data and they just give you the mean and the median? If they just give you the mean and the median, will that tell you if it's skewed or not? What if the mean and the median are the same? Okay, then we know it's symmetric, right? It could be bimodal and symmetric, and the mean and the median could be in the bottom, right, down in the trough of the two. Doesn't mean that it is a beautiful bell-shaped curve, okay? So if the mean and the median are the same, then it's symmetric. What if the mean is higher than the median? If the mean is higher than the median? So if your mean is higher, here's your mean over here, right? Higher than the median. If the mean is higher, that means the mean is being pulled into that tail, right? That means there's some high numbers down there. So is that skewed left or skewed right? Skewed right. Okay, very good. So if they give you the information, sometimes, this is crazy, our eyeballs will look at a histogram and we're like, oh, that's totally skewed left. But then when you look at the numbers, you're like, oh, it's not. Because sometimes they're not pretty. Sometimes you'll have like a couple of high ones, some in the middle, and then, and it's just not a beautiful graph. And your brain will play tricks on you when you're looking at a picture. So sometimes a picture doesn't do the job. Sometimes we have to go straight to the numbers, okay? So make sure that you watch out for that. All right, so we all know how to find the mean. We call it our X bar. So all you have to do is add up the observations, divide by the number of observations. You might see it like this. It has a sum instead of all the addition, okay? And then I just stands for all the number of observations that you have, and then you divide it out, okay? So we all do know that. Your mean is not resistant to outliers. One large observation, like that NFL player moving into Bremen, would skew our average salary, our yearly salary, okay? So the mean is not resistant to outliers. All right, the median, we know how to find it. You have to arrange all the numbers from smallest to largest, and then we count to the middle. What if there are two middle numbers? You add them up and divide. Remember, you find the average of the two middle numbers if there are two middle numbers. The beauty of this is you can put this in your calculator, you can sort it ascending, and you can go to your one variable analysis, right? You can go to one variable stats. It'll give you your mean. It will give you your median, which is beautiful. But you also want to know how, like, where will they kind of fall in a picture? If they only give me a picture and they don't give me numbers, where does it look like it's going to fall, okay? All right, so means and medians behave differently. The median is resistant. If I have somebody over here that makes no money and I have somebody over here that makes millions of dollars, that's not really going to affect the mean, right? Because you're just still counting to the middle. You add an extra one on this end, still going to count to the middle, right? So the median is resistant, okay? All right, if it's symmetric, they're equal. If it is skewed, we know the mean is further in the tail. Are we good? All right, if I say average, we know we're talking about a mean. Typical value usually means median, which you probably won't see that a whole lot, but. All right, the range can absolutely be used. The range is your highest number minus your lowest number. I'm still in debate about this right here, because technically your range is when you subtract those two. So let's just say that the highest grade in here was an 80 in class. on your first test. And the lowest grade was a 60. So my range would be a 20. What does that 20 tell you? I still get frustrated every time we do it because 20 doesn't tell me anything about, hey, how are the scores on your first test? And well, the range was 20. Well, was it like 80 to 100? Or was it 40 to 20? Like, what does that mean? So when I do the range, I always show these two numbers being subtracted. Because if you don't show that, then what the heck does the 20 mean? It doesn't mean anything, right? It's kind of ridiculous. So I always make sure to show those numbers, okay? All right, so your quartiles are used to show, that is another measure of spread. So right here, this is another measure of spread, are your quartiles, okay? And your interquartile range is Q3, take away Q1, and this is your middle 50%. It's the box of the box and whisker. Now, when should you use IQR? When the median is our center. So if you're going to use the median as your center, oh, and when do you use the median as your center? Okay, when there's outliers, or if we have skewed values. You can have a very symmetric, beautiful graph and still have an outlier over there. Okay? So that means even if it's beautiful and symmetric, but you have an outlier over there, your best bet is to use the median. So always check for outliers. You know how to now graphically. Okay. All right, so your quartiles are used. Again, how do we find our quartiles? Well, if we know where our median is, which is in the very middle, then I take this first half, which is the first 50%, I count to the middle, and that's where Q1 is. Then I take my second half, and I count to the middle, and that's where my Q3 is. Okay? Now, it's fantastic when they give you the numbers and you can crunch it in your calculator, but you're going to find out on Monday, I'm going to give you an AP problem, a Frappy, and that Frappy just gives you some quartile information and does not give you the full set of data. So then you're going to have to use your knowledge based on what's a Q1, what's a Q3, what's an outlier, okay, to be able to determine some stuff, okay? All right, so Q1, Q3, know that those are kind of our 25% markings, okay? All right, so looking at this right here, this is our highway mileage of 20 gasoline cars arranged in order. Okay, so this is what the mileage they get, I guess, per gallon or something like that. And it says to find the mean, median, Q1, and Q3, okay? Now, if I look at this right here, I'm wondering if there's an outlier. Look at your data. It's in order for you. Does it appear there might be an outlier? What is it? 66, but we're not really sure if it's an outlier or not, okay? It appears that it could be, but we're not really sure. Now, this is a Minitab. Like I said, you're going to look at a lot of computer outputs. Minitab is a fantastic program. Like I said, take it in college. Just take it. It's fun, okay? If they still offer it, it's probably called something different now. But Minitab, they'll give you a statistical output. Right here, it tells me the number of pieces of information I should have, and this says 50. Then we have our mean, our median, our truncated mean, which we're not going to use. So if y'all want to mark that off on your, if you have that little, is it? Can you even read it? Okay, I'm sorry. Okay. And then right here, we do have our min, our max, our Q1, our Q3, and Q2 is our median, which is right there. Okay, so if they do give you a statistical output, then you could still make a box plot. When I graph a box plot, what do I have to graph it on? A number line, right? You got to graph it on a number line. Or how do we really know what it's going to look like if it's not based on the number line? So just make sure that you do that, okay? All right, so I want y'all to go ahead and put this data in your calculator. I'm trying to see if y'all can see that data on your paper or not. Yep. All right, go ahead and put the data in. Let's really see if we have an outlier. actually have a mode. All right, put that data in. Let's look at that data. And then I'm going to reveal to you our wonderful outlier rule. All right, so we landed on row 21, which means I do have 20 pieces of data in. Okay, so always make sure that you're landing where you're supposed to. And always double check your data. All right, so I'm just going to look real quick to make sure it doesn't look like I have anything unusual in there. It doesn't appear that I do. All right, so let's go ahead and do a modified box plot. So second stat plot. Enter. Modified box plot has the asterisk on the end. And once you have your list 1 should stay. That's where our data is. Frequency is 1. I'm going to zoom 9. Woo! Does there appear to be an outlier? Yes. Absolutely. Okay, so how do you create a modified box plot versus a regular box plot? Okay, so let's see what the regular one looks like. So let's do something fun. Go back to stat plot, second stat plot. Go down to plot 2. It should be off, but let's turn it on. Turn on plot 2. Make sure it's on. And then I want you to go to a regular box plot. And highlight the regular box plot. And we're going to put list 1 again. Okay, the same thing, same data. But I would like to see a regular box plot and a modified box plot next to each other. Okay? All right, and then my frequency is 1. At this point, I can zoom 9. And there we go. All right, so we can definitely see we have some skewed data there. If I were to draw a histogram over this data, we can see how skewed it is. It's skewed right. It is tailed to the right, okay? So we can definitely see our curve would be tailed to the right if we were looking at a density curve. All right, now, how did they get this information? How did they change their whiskers? So this is our rule. It's somewhere in your notes, but you can write it in the margins. It's called the 1.5 IQR rule. And this is our outlier rule. So we're going to use this easy set of data. After I finish this problem, I'm going to be done for the day. So hang on there. We're going to use the 1.5 IQR rule. All right, so what we are going to do is this. We are going to come up with this magic number. We're going to do 1.5 times my IQR, which is Q3 take away Q1. This is called my IQR, my interquartile range, my box. And so we need to figure out what our Q3 and our Q1 are, okay? So first I'm going to go ahead, I'm just going to press trace. And if you press trace, it'll give us some good information here. So my Q3 is 27. And then arrow over, and my Q1 is 18. Now, basically what we're saying is this. This is what the 1.5 IQR rule says. If you, let me see if you can still see that. There we go. If you fall outside of my box by this much, then you're an outlier, okay? Because the box is the middle 50%, so this is all based on the box, okay? So I'm going to get this magic number right here, and if I fall outside of the box by that much, then I'm an outlier, okay? All right, so 27, let's go ahead and do this. There we go. And did you get 13.5? Okay, so 13.5, this is our magic number right here. This is where I'm basically going to add 13.5 or subtract 13.5 from the box. Okay, so I'm going to come over here and I'm going to label this box right here. So this box this is 18 and this is 27. Okay, so what I'm going to do is I'm going to take this magic number right here, 13.5, and I'm going to add 13.5 to Q3 to see if I'm 13.5 outside of the box in this direction, then I'm an outlier. Okay, so I'm going to add that to 27. and I get 40.5. So somewhere around, and I don't know how this is counting down here. I don't know how this is counting. But if I look at this, if I go somewhere to wherever 40 might be, okay? So we have a fence at 40. I don't know if this is counting by like 10, 20, 30, 40, 50, 60. It might be counting right around there. 10, 20, 30. So right around 40, what is it, 40.5? I call it like a little fence, okay? And if any of my observations fall that far outside of the box on that end, then it is an outlier. But I also have to do the same thing on this end, so I need to subtract that 1.5 IQR from the other end, and I get 4.5. And so somewhere around 4.5 is my lower fence. So I have an upper fence, and that's kind of the cutoff for an outlier, and then I have my lower fence at 4.5. So you're going to do Q3 plus your 1.5 IQR, and then you're going to actually do Q1 minus your 1.5 IQR, okay? Because you got to be either outside the box in this direction or that direction, okay? All right, so you can see if I go back to my list of numbers, and they are in order right here, I don't have anything below 4.5, so there's no outliers on that direct or on that end. But if I come over here, 32 and then 66, okay? So that 66 is clearly the outlier. But now my question is, how do they change the graph? Okay, how did they change the graph? How did they change the whisker from that whisker to that whisker? What do you think they did? Okay, so this one's drawn to 66, and we know that 66 is the outlier here. How do I know where this ends right there?
It's going to be the next highest number, isn't it?
That's right. It's going to be the next observation that isn't an outlier. So it should be 32, right? 32. So we're going to trace it, and we can move over, and it is 32, because that was the next number on the list that wasn't an outlier. So if you're drawing a box plot, you'll just have to decrease that whisker so that it is the next observation that is not an outlier. Does that make sense? Are you good? All right, so that is your outlier rule. That is the same rule that your graphing calculator used to determine that 66 was an outlier and that Sarah Predator was not. All right, I'm done for the day. You guys have a good Friday, good weekend.